We use this thing called the binomial theorem to expand binomials. And a binomial is a polynomial with two terms. And when binomials are raised to a power, we have a quick way of expanding them, the theorem. So if I have x plus y to the 0, of course anything to the 0 power is 1. X plus y to the first power is just x plus y. You've probably seen x plus y squared. If you FOIL it, you get x squared plus 2xy plus y squared, and so on. Well, there turns out there's a pattern to these coefficients. So when it's cubed, it's 1, 3, 3, 1. And what's to the fourth, it's 1, 4, 6, 4, 1. And the binomial theorem is what gives us these coefficients. So here it is. In the expansion of x plus y to the nth power, the expansion is x to the n plus n, x to the n minus 1y, plus dot, 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 and this looks like a bunch of gibberish. But there is a pattern, so don't worry, okay? It turns out that the coefficient of x to the n minus r times y to the r term is what we call n choose r. It's a combination, okay? It's n factorial over n minus r factorial, and sometimes you'll see it written as parentheses n over r like that. But what that means is n factorial over n minus r factorial, r factorial. So for example, 8 choose 3, that's going to be 8 factorial over 8 minus 3 factorial, 3 factorial, which works out to 8 factorial over 5 factorial, 3 factorial. Fortunately, our graphing calculators can work that out, and I'm going to hit alpha F2. I'm going to choose number 8, and I'm just going to put in 8 right there over 3 right there, and we get 56. Okay, if you've got an older model, you can go to Math and then over to Probability, and there it is right there, the third menu item. Okay, and also there's a factorial, the fourth menu item, if you want to use that. Okay? Okay, so now let's actually use the binomial theorem to expand this binomial x minus 4 to the 5th power, which is a lot easier, trust me, than multiplying out longhand x minus 4 times x minus 4 times x minus 4 5 times. Okay, so here we go. Let's see if we can find some patterns here. So we're going to start with 5 choose 0, x to the 5th, negative 4 to the 0, plus 5 choose 1, x to the 4th, negative 4 to the 1st, plus 5 choose 2, x cubed, negative 4 squared, plus 5 choose 3, x squared, negative 4 cubed, plus 5 choose 4, x, negative 4 to the 4th, plus 5 choose 5, x to the 0, negative 4 to the 5th. Barely got it in there. Okay, so let's see what the pattern is. You'll notice that the exponent of my second term will always match that number right there. Okay? And let's look at the exponents of the first term. They count down. So it's going to go 5, 4, 3, 2, 1, 0, while the exponents of the second term count up. 0, 1, 2, 3, 4, 5. Okay? So that's the pattern. Once you know it, it's not too bad. All right, so if we work these out, and I went ahead and worked them out ahead of time, you're going to get 1 x to the 5th times negative 4 to the 0, which is 1. 5 choose 1 is 5. X to the 4th times negative 4 to the 1st. 5 choose 2 is 10. X cubed, and then negative 4 squared is positive 16. 5 choose 3 is also 10. Then I get x squared, and negative 4 cubed is negative 64. 5 choose 4 is 5, and that's x to the 1st, and negative 4 to the 4th is 256. And then finally, 5 choose 5 is 1, x to the 0 is also 1, negative 4 to the 5th is negative 1024. So, final multiplication here, I've got x to the 5th minus 20x to the fourth plus 160x cubed minus 640x squared plus 1280x minus 1024. And this is what you get if you multiply it out, x minus 4 times itself 5 times. Okay, so there's an even better shortcut for getting these coefficients, and that's a mathematical thing called Pascal's triangle. How's it work? Well, you start with 3 ones like that, okay? And then every row is going to start with 1 and end with 1, and you get the numbers in between by adding the 2 numbers that are above it. So 1 plus 1 will give me 2. Okay, now I start with 1. 1 plus 2 gives me 3. 2 plus 1 gives me 3. And then end with 1. Start with 1 again. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And this is 1. Now, guess what? These numbers are the coefficients of your binomial expansion. We call this the 0th row. This is the first row. This is the second row, third, and fourth. Okay? So let's use Pascal's triangle to expand 2x minus 3 to the fourth. So I'm going to go to the fourth row since I'm raising it to the fourth power. And my first coefficient is 1. So I have 2x to the fourth. And remember that negative 3 is raised to the 0 power. My next coefficient is 4. The exponents of 2x count down, while the exponents of negative 3 count up. My next coefficient is 6. 2x cubed, negative 3 squared, plus 4. Whoop, made a mistake, didn't I? That should be 2x squared. And here's a way you can catch your mistakes. The exponents should always add up to what this original exponent is. So 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4. Okay, and then I have 2x to the first, negative 3 cubed, and then finally 1, 2x to the 0, negative 3 to the fourth. And then I just work this out, okay? So I'm going to get 16x to the fourth minus 96x cubed. That's 4 times 2 cubed times negative 3 plus 216x squared. That's 6 times 2 squared times negative 3 squared minus 216x. That's 4 times 2 times negative 3 cubed. And then finally, negative 3 to the fourth is positive 81. Okay, last example. What if I just want to find one term and not want to do the entire binomial expansion? Well, that's not too bad. If I want to find the y to the fifth term, that means I'm going to have y to the fifth, and the first term's exponent has to add up to 9, so it's going to be to the fourth, and that means I've got 9 choose 5. Okay? And that works out to 126 times 3 to the fourth times y to the fifth, which is 10,206 y to the fifth. Now this 126, remember, that came from 9 factorial over 9 minus 5 factorial times 5 factorial. And that's where I got the 126.